We are going to continue today and do the rest of the examples on the 9.1 notes page from yesterday. I believe a couple of the example numbers are slightly different on the notes page that you have, but make sure that you complete all of the examples that I have here in these notes. Alright, so the first example we're going to look at is a formula for finding the parametric arc length. So this is different from when we were doing the arc length of a regular equation. So we just have the formula. We're still integrating from a to b. So this is going to be t equals a to t equals b, and then it's going to be the square root of x prime squared plus y prime squared. Alright, so they've given us an x equation and a y equation, and they've told us the a and b values. So the first thing I'm going to do is find x prime and y prime. So we have dx dt is going to equal, we're just going to do the power rule, so we've got 2t, and we have dy dt is equal to 12t squared. Alright, so what I'm going to do is I'm just going to plug that into my formula. So I have L is equal to the integral from t equaling 0 to t equaling 1. And we've got the square root of, we've got dx dt squared, so dx dt is just 2t, plus dy dt squared, which is 12t squared, squared. Don't forget the dt at the end. The dt should not be underneath the radical. So now we're just going to do some algebra. So I've got L is equal to the integral from 0 to 1. I've got the square root of 4t squared plus 144t to the 4th dt. And I'm going to factor out. So I've got L is equal to the integral from 0 to 1. I'm going to factor out a 4t squared. That's going to leave me with 1 plus 36t squared. And the nice thing about the 4t squared is that it is a perfect square. So I've got L is equal to the integral from 0 to 1. What I really have is a 2t on the outside and the square root of 1 plus 36t squared underneath dt. Now this has set me up for a u sub integral. So we've got u is equal to 1 plus 36t squared, which means du is equal to 72t dt. So dt is equal to du over 72t. So now I'm going to set up into my integral, putting in my u sub. So I've got L is equal to the integral of, now I'm going to change my u sub. So I'm going to take the 0, plug into 1 plus 36t squared, and so my a value becomes 1. And then I'm going to take the b equals 1, I'm going to plug into my u equation. So 1 plus 36 times 1 squared, this becomes 37. When I sub in, I've got 1 over 36 u to the 1/2 du. Now when I integrate, we've got L is equal to, we still got 1 over 36. Now I'm integrating to 2 over 3 u to the 3/2. That needs to be evaluated from 1 to 37. By changing my a and b values, I don't have to sub back in my u. And so we get an L value of, I've got 1 over 54 by simplifying those fractions. Now 37 to the 3/2 cannot be simplified. So I'm just going to leave it like this. Alright, so that is an arc length. So what we have here is a notes page, and a couple of things I want to point out. So now we can talk about what dx dt means. So dx dt is just going to be our velocity in the x direction, or the horizontal direction. Dy dt is going to be the velocity in the y direction, or the vertical direction. We can write a velocity vector, which is just going to be x prime of t comma y prime of t, notice the arrows instead of the parentheses. And so it looks like the top of an arrow. So make sure that when you're writing those velocity vectors and the acceleration vector, that it doesn't look like a parentheses, it doesn't look like a bracket, it actually looks like the top of an arrow. Alright, so we've done dy dx. We've talked about how it's dy dt divided by dx dt, and it's saying that it's the slope of the position vector. D2y dx2. So be careful with that formula. So remember that this is d dt of dy dx divided by dx dt. So make sure you're careful with that formula. Alright, so the next one we have the speed of a particle, which could also be called the magnitude of the velocity vector. So when they ask for the magnitude of the velocity vector, the way that we name that is the absolute value of the velocity vector. That's how we will name that. We have the length of an arc, or they could say the distance traveled. Alright, so make sure that you are mindful of all of these formulas. So example 8. So they've given us an x of t equation, a y of t equation. We're going to find the velocity vector at t equals 1, and then we're going to find the acceleration vector at t equals 2. I think this is slightly different from what is on the notes page that I posted. So the first thing I want to find is x prime of t. So I'm going to find x prime of t, which is equal to, we've got 3t squared plus 8t. And then we're going to find y prime of t. Y prime of t, which is equal to 4t cubed minus 3t squared. Alright, so first I can write a velocity vector, and then I can show the velocity vector evaluated at 1. So if I'm just writing the vector itself, so we've got v with the vector symbol is equal to, remember we're doing the head of the arrow, and then I'm just going to put in x prime of t, comma, y prime of t. And then on the other side, the head of another arrow. So that would be the velocity vector. So the velocity vector evaluated at 1. So now I'm just going to sub in those values. So if I plug 1 into x prime of t, I get 3 plus 8, which is 11, comma, and if I plug 1 into the y prime of t, 4 minus 3 gives me 1. Right. Now for the acceleration vector, now we just need x double prime of t and y double prime of t. So x double prime of t, we already know x prime, so we're going to take the derivative again, 6t plus 8. And then y double prime of t is going to equal 12t squared minus 6t. So I can write the acceleration vector, and then I can show the acceleration vector evaluated at 2. So first let's write the acceleration. So a vector symbol is equal to sharp point. So we have 6t plus 8, comma, 12t squared minus 6t. And then we can evaluate that at, so my paper is asking us to evaluate at 2. So if I take 2 and plug into x double prime of t, we get 6 times 2 plus 8, which is going to give us 20, comma. Now if I take 2 and plug into y double prime of t, so we've got 12 times 2 squared minus 6 times 2, which is going to give us 36. So example 9 has given us a new x of t and y of t equation, and it's asking us to find the magnitude of the velocity vector. So remember, it's just a formula from our notes page, and we said that we're going to use this absolute value of the velocity vector when we are naming it. So I can say that's actually equal to that equation. So again, I need to know dx dt and dy dt. So let's find that first. So dx dt is equal to, and whether you're calling it dx dt or x prime of t does not matter. So we've got 2t plus 3, and then dy dt is equal to 3t squared minus 6t. So now we're just going to plug that into our formula. So I've got the absolute value of the velocity vector is equal to the square root. So I'm going to plug in my dx dt. So I've got 2t plus 3 squared plus plug in my dy dt. So 3t squared minus 6t squared. And it's asking at t equaling 1. So we're just going to plug in a value of t equaling 1. So if I plug 1 into the first parentheses, 2 times 1 plus 3, 5 squared is 25, plus 3 times 1 squared minus 6 times 1. So I've got a negative 3 squared is a positive 9. So the magnitude is just going to be the square root of 34. So that is the magnitude of the velocity vector.